I have maximization problem and two constraint. So what is the first step? So first step is you have to convert this inequality of constraint into equality. Elements of the first column of the unit matrix, it is 0, divided by corresponding elements of the entering column is again 4. Now you can cross verify whether these values are satisfying the optimality condition or not. Hello everyone, I am Shweta, Computer Science Faculty, Vidhyaashram First Grade College, Mysuru. In my last session, I have discussed about two-phase method. Those who have learnt Simplex method, they can easily solve B.C.A method and two-phase method. So today I will discuss another problem in LPP, that is degeneracy in LPP. So what is the meaning of this degeneracy? So already I have discussed about Simplex method and B.C.A method, two-phase method. So in Simplex method, what you will do is, when you selected the key row, in ratio, you have to choose one least positive number. When you are selecting the key row, you have to select in ratio, you are selecting the least positive value. But if you get both the values are same, that means tie between two values or three values, how do you select the key row? That conditions is known as degeneracy. So how to solve this degeneracy in LPP? I will explain it one by one. In any given iteration in a linear programming problem, either by Simplex or B.C.A method, the living row is found by selecting that row. Living row means it is a key row. When you are selecting the key row or living row, which has the least positive value in the ratio column, isn't it? But if there is a tie between two rows, that means if you have 2, 2 and 2, there is a tie between two or more rows, that is, they have identical least positive values. Then there is said to be degeneracy in LPP. That condition or that complication is called as degeneracy in LPP. And this basically results when there are more than two lines crossing each other that make a vertex in the solution space. Example, here 3 lines crossing each other to form a vertex. 2 lines crossing each other that make a vertex in the solution space. So degeneracy in LPP may result in the Simplex procedure to cycle indefinitely. That is, the Simplex may move from one iteration to another iteration without any improvement in the solution. Sometimes this degeneracy will occur in Simplex method, B.C.A method or two-phase method. So when you are selecting the living row in the sense key row, when you are selecting the key row, if you get same value, 2 or more values are same in a ratio column, that complication is called as degeneracy in LPP. So now let us understand with an example of degeneracy in LPP by Simplex method. Already you know about Simplex method, right? So same method I am doing again, but I will show you the degeneracy condition in Simplex method. So I have maximization problem and two constraint. So what is the first step? So first step is you have to convert this inequality of constraint into equality. Max z is equal to 3x1 plus 9x2 and subject to constraint x1 plus 4x2 plus s1. So I am adding slack variables for converting inequality into equality. And the second constraint x1 plus 2x2 plus s2. Slack variable 2 is equal to 4. So here 0 s1 0 s2 I am adding Coefficient of S1 is 0, coefficient of S2 is also 0. So now it is in a standard form. Next I will prepare initial simplex table. Initial simplex table. So next step, you just write this table and write this basic variable first. X1, X2, S1 and S2. We have 4 basic variables and coefficient of X1, X2, S1, S2. So what is the coefficient of X1? 3, X2 is 9, S1 is 0, S2 is 0. We have to find the ratio. And here I will take the slack variables, this 0 S1, 0 S2. When you are solving Big M method, so your coefficient of Big M method is minus m A1 basic variable minus m A2 basic variable. And when you are solving two-phase method, so your basic variables are A1, A1, but here minus 1, minus 1. Coefficient is minus 1 and minus 1. So in simplex method, you have to add the slack variables S1 and S2, coefficient is 0 and 0. And in this place, you have to write the equation number 1 and equation number 2 coefficients. So x1 coefficient in equation number 1 is 1, 4, S1 is there, S2 is not there, solution is 8. And equation number 2, x1 is 1, x2 2, S1 is not there, S2 is 1 and solution is 4. So after this, what is the next step? We have to find the Zj value. How to find the Zj value? 0 into 1 plus 0 into 1, it is 0. So in simplex method, in initial simplex table, all Zj values is always 0. And next we have to find Cj minus Zj. 3 minus 0, Cj minus Zj. 3 minus 0, 3. 9 minus 0, 0 minus 0, 0 minus 0. So after this, we have to check these values are satisfying the optimality condition or not. Already I have discussed this so many times. When it is maximization problem, all Cj minus Zj value should be less than or equal to 0. That means negative or should be 0. And Cj minus Zj value should be greater than or equal to 0, positive or 0. So here it is maximization problem. So all the Cj minus Zj value should be negative or 0. Till that we have to do the iteration. So here we have positive and 0 values. So here I have positive values. So positive value means it's not satisfying the optimality condition. Not satisfying optimality condition. Optimality condition. So we can move further. So after finding the optimality condition, if it is not satisfying, we can move further. So we can proceed for next iteration. So before that, we have to find key column and key row and key element. So here I will select the maximum value. Out of this, we have to select the maximum value, maximum positive value. Maximum positive value is 9. So it comes under x2 column. So this column is called as key column. So x2 is my key column. I will mark this key column. So after this, we have to find the ratio value for getting the key row. Ratio means solution divided by key column. Solution is 8 divided by 4, it is 2. And 4 divided by 2. So 4 by 2, it is also 2. So now you can find the key row, that means living variable. Here in ratio column, I have to select the least positive value, right? So both the values are same. Both the values are positive and both the values are equal. So how to select this least positive value here? Both the values are same. So this condition is called as degeneracy in LPP. So we have both the values are same. This condition is called as degeneracy in LPP. So tie between two values. So here we have 2 and 2 only. So how to select the key row or living variable in degeneracy. You have to use one simple step. You have to follow one formula for finding the least positive value in ratio column. So what is the formula for finding the least positive value? Min of elements of the first column of the unit matrix, elements of the first column of the unit matrix divided by min of elements of the first column of the unit matrix divided by corresponding elements of the entering column. Corresponding elements of the entering column. So this is a formula for finding the least positive value when we get the degeneracy in LPP. Min of elements of the first column of the unit matrix. So what is the meaning of unit matrix? So I hope already have studied in second PUC, right? So this is one unit matrix. So all the diagonal value is 1. Always should be 1. Then we can call it as it is a unit matrix. So this is for 3 cross 3 matrix 1 0 0 1. So here diagonal matrix is 1. So all the diagonal value should be 1. Then we can call it as it is a unit matrix, right? So here I have only 2 variables. So in this problem I can select only 2 cross 2 unit matrix. 0 1 1 0 0 1 1 0 0 1. This is one unit matrix, right? In this problem I have only 2 variables, that is x1 and s2. And if you get 3 variables, so obviously you will get 3 cross 3 unit matrix, that is 1 0 0 0 1 0 0 0 1. So here I have only 2 variables, so I will get 1 0 0 1, that is 2 cross 2 matrix, that means 2 cross 2 unit matrix. So here I have unit matrix 1 0 0 1. You just select that unit matrix, but this is not a key column or key column. I am selecting only, it is a unit matrix. I am selecting the unit matrix for finding the least positive value in the ratio. So here I am using this formula, min of elements of the first column of the unit matrix divided by corresponding elements of the entering column. Corresponding elements of the entering column. So here key column is 4 and 2, right? So here corresponding elements of the entering column. For 1, corresponding value is 4. Elements of the first column of the unit matrix, that is 1. This is 1, I am taking 1. And divided by corresponding elements of the entering column. Corresponding element of the entering column, that means 1 divided by 4. So I will write here 1 divided by 4, that is 0.25. I will repeat. So here I am taking only 2 cross 2 unit matrix, 2 cross 2 or it can be 3 cross 3 also. I am selecting 2 unit matrix, 1 0 0 1 is my unit matrix. For finding the least positive value in a ratio column, I am selecting the unit matrix. After that I am applying this formula, min of elements of the first column of the unit matrix. This is first element, first column of the unit matrix divided by corresponding elements of the entering column. So this is my key column. I will select this elements of the first column of the living variable, that is 1 divided by 4 and 0 divided by 2. 1 divided by 4 means you will get 0.25 and 0 divided by 2 means you will get 0. No need to write. I have written only 1 by 4, it is 0.25. And next unit matrix. Again 0 means elements of the first column of the unit matrix, it is 0, divided by corresponding elements of the entering column is again 4. And next element is 0, corresponding element of the entering column is 2. So 0 by 2 is 0 only, no need to write that. And second column means second unit matrix, 0 divided by 4 and 1 divided by 2. I will repeat, first unit matrix, second unit matrix, 1 divided by 4, 0 divided by 2. 1 by 4 is 0.25. 1 by 4 means 0.25, have written in tie column, and 0 by 2 no need to write, it is 0 only. And again I will select this second column, 0 by 4 and second value is 0 by 2. So I will write 0 by 2. So 0 by 2 is, it is 0 only. So here I got two values, that is 0.25 and 0. So here you have two unit matrix. If you want to select the first unit matrix, you can take, or else you can take second unit matrix also for taking the least positive value. So here I am selecting 1 by 4 and 0 by 4. So if you want to take 0 by 4 and 1 by 2, you can take it. So 0 by 4 means it is 0 only. 1 by 2. 1 by 2 means it is 0.5. So again you are selecting the least positive value. So least positive value is 2. So here I am taking, this is my key row. Living variable is S2. So here I have selected S2 is my living variable because I got 1 by 4 is equal to 0.25 and 0 by 2 is equal to 0. In degeneracy, usually you will get 0 point something value. So out of 0.25 and 0, so you can select this 0 is a least positive value. And least positive value comes under S2. So S2 is my living variable. It is very simple concept. In degeneracy in LPP, you will get same positive value. Same positive value means it is tie between the values. So you can use this formula, min of elements of the first column of the unit matrix by corresponding elements of the entering column. So usually you will get unit matrix, you just mark the unit matrix. If you want to take the first unit matrix, you can take, or else you can take the second unit matrix also. So here I have taken 1 by 4 and 0 by 2. If you want to select 0 by 4 and 1 by 2, also same thing, you will get S2 is your key row. So now S2 is living variable and X2 is entering variable. In next iteration, I will write in place of S2, I will write X2. Iteration 1, X1, X2, S1, S2, solution and ratio. Just write all the coefficient of objective function 0 and 0, and here I am writing in place of S2, I will write it is X2. S1 is same and in place of S2 I have written X2. So X2 coefficient is 9. Now you can cross check the key element. So what is the key element? Common for both key row and key column is 2. So key element is 2. Key element is equal to 2. Now find out key row and non-key row. Using old values, we can find the new values. So first list all the key rows. So what are the key rows? 1, 2, 0, 1, 4. 1, 2, 0, 1, 4. So key element is 2. So what is the formula for finding key row? Old value by key element. Old value is 1, key element is 2, it is 1 by 2, 2 by 2 is 1, 0 by 2 is 0, 1 by 2 is 1 by 2, 4 by 2 is 2. So now I will write the new values 1 by 2, 1, 0, 1 by 2 and 2. So these are the new values and list all the non-key row values. 14108. 14108. So now find out the new values. New values. How to find the new values? Using non-key rows. So here old value is 1. Corresponding key column is 4. Corresponding key column is same to all the values. Old value is 1. Corresponding key column is 1 and key row is 1. So 1 minus 4 into 1 by 2. 1 minus 4 into 1 by 2. 2 ones are 2 twos are. So 1 minus 2 is minus 1. Next old value is 4. Corresponding key column also 4 and key row is 2. So 4 minus 4 into 2 by 2. So 4 get cancelled. So 4 minus 4 is 0. And old value is 1. Corresponding key column is 4 and key row is 0. So 1 minus 4 into 0 by 2. 1 minus 4 into 0 by 2. So 0 into 4 is 0. It is 1. And old value is 0. Corresponding key column is 4 and key row is 1. So 0 minus 4 into 1 by 2. 0 minus 4 into 1 by 2. 2 ones are 2 twos are, it is minus 2. And old value is 8. Corresponding key column is 4 and key row is 4. So 8 minus 4 into 4 by 2. 8 minus 4 into 4 by 2. So 2 ones are 2 twos are. 8 minus 8, it is 0. So now we can find Zj value. So 0 into all the numbers are 0. So first column is 0 and 9 into 1 by 2 is 9 by 2. 9 into 1 is 9. 9 into 0 is 0. 9 into 1 by 2, it is 9 by 2. 9 into 2 is 18. So now you can find Cj minus Zj. 3 minus 9 by 2. 3 minus 9 by 2, take LCM. 2 is LCM. 6 minus 9 by 2, it is minus 3 by 2. And 9 minus 9, 0. 0 minus 0, 0 minus 9 by 2, minus 9 by 2. Now you can cross verify whether these values are satisfying the optimality condition or not. So here I have negative value, 0, 0 and negative value. So it is satisfying the optimality condition. So we can stop the iteration here. So now you can find the maximum value. So max z is equal to 18. Max z is equal to 18. So what is the value of x1? x1 is not there, so it is 0. And x2 value is 2. x2 is equal to 2. So x1 value and x2 value is 0 and 2. Now you can cross verify the answer. Max z is equal to 3x1 plus 9x2. So max z is equal to 18. 3 into x1 value is 0 plus 9 into x2 value is 2. So 9 into 2 is 18. So 18 is equal to 18. LHS is equal to RHS. So it's satisfying the optimality solution. So this is about your degeneracy in LPP. If you get any same value in ratio column, you can go for degeneracy concepts. You have to use min of elements of the first column in the unit matrix divided by elements of the corresponding living variable. So you can use this formula for finding the least positive value in ratio column. So this method is called as degeneracy in LPP. It is very simple concept. So we can use for simplex method, B.C.A method and also for two-phase method. If you get same value in ratio column, you can go for this concept. In my next session, I will discuss about the new topic called duality. Thank you.